Good morning friends. In this lecture I am going to discuss a very interesting topic students. The topic name is surface integral. What students? Surface integral. In surface integral we mainly discuss the basic concept, some formulae and physical interpretation of surface integral. Okay students, let us see the concept students. Surface integral. Let f bar that is equal to f1 I bar plus f2 j bar plus f3 k bar be continuous differentiable vector point function. What students? F bar is continuous differentiable vector point function. Right. The surface integral of f bar. The surface integral deals students double integration of f bar over a surface S. Where students? Over surface. Say this is surface students. This is surface S. Defined as, it is defined as integral over S f bar dot n bar ds var r double integral over r f bar dot n bar ds. Once again students, integral over S. Integral over S means it is double integration. Once again students, integral over S means it is double integration. Where students? Over S. Says this is surface students. Okay, right. Now f bar students. What is f bar? F bar is a given vector point function. Or students, given vector point function. N bar. N bar students. N bar is outward. This is very important students. N bar is outward normal to the surface. See students here. This is outward normal to the surface S. Once again students, N bar is outward unit normal vector to the surface S students. Okay. Now ds students. ds is a small part. Students, say this is ds. ds is small part of surface S students. ds is small part of the S students. Okay students, now if we add all such regions, then we get the value of integral over S f bar dot n bar ds students. ds. Okay, to evaluate such type of integration, we need to take the projection of the surface in the plane students. Okay students, once again, to evaluate such type of integrations, we need to take the projection of the surface in the plane students. What are the planes students here? What are the planes? Come on, tell me everybody. XY plane, XZ plane or YZ plane students. YZ plane. Suppose if I am taking the projection of the surface S on XY plane students, on XY plane, then let us see the formula students. The formula. If R1 be the orthogonal projection of S, see students, say this region is small region is R1. Okay, this is orthogonal projection students of S on XY plane. Say this is, we know students, this is XY plane. Now integral over S f bar dot n bar ds. See students, integral over S f bar dot n bar ds, that is equal to double integral over where students? R1. Double integral over R1. This value is equal to double integral over R1 f bar dot n bar. See students, this is xy plane, so that we get here dx dy divided by modulus n bar dot k bar. What students? Modulus n bar dot k bar. That means in ds place we have students dx dy by modulus n bar dot k bar students. K bar. Okay, actually we get here in place of n bar dot k bar we get cos gamma students. Cos gamma. By applying the basic definition we get here modulus n bar dot k bar students. It is enough to remember. We get modulus n bar dot k bar students. Modulus n bar dot k bar. Now, if I am taking the projection on yz plane students, what students? If I am taking the projection of this S in yz plane students, yz plane. Come on, tell me students, yz plane then. Integral S f bar dot n bar ds, that is equal to double integral over r to f bar dot n bar. Since it is a yz plane, dy dz. What students? Dy dz divided by modulus n bar dot, what is outward students here? I bar. So n bar dot I bar. N bar dot I bar. Now you can guess students. Now you can guess xz plane students. You can guess xz plane. See students, if R3 be the orthogonal projection of S on xz plane. Xz plane students. Now xz plane means students, we can guess now the denominator. What is denominator students? N bar dot j bar students. N bar dot j bar. See, integral S f bar dot n bar ds, that is equal to double integral of R3 f bar dot n bar dx dz by modulus n bar dot j bar. Modulus n bar dot j bar. Okay students, now if I am taking here parallel piped students or cube. Okay students, if I am taking cube or parallel piped. Okay, now if we observe here the region R1 students, R1, where is R1 students? At any point on Z students, which is parallel to xy plane. Okay students, now what is outward unit normal vector students here? What is outward unit normal vector along the Z? What is the unit normal vector students? K bar. Or students, K bar. Now see students, see here this formula becomes here integral over S f bar dot n bar dx, that is equal to, come on tell me students, integral over double integral r1 f bar dot, come on tell me students, what is the outward unit normal vector here? Outward unit normal vector k bar students, k bar. So n bar becomes here k bar into dx dy divided by k bar dot k bar students. What is value? K bar dot k bar value 1 students, 1. Okay students, similarly if I am taking here yz plane, then I get students here, then I get yz plane, I get here f bar dot I bar. So the denominator value is 0, sorry, denominator value is 1. If I am taking xz plane students, I can write n bar plus j students. So j bar dot j bar value 1. Okay students, this is about surface integral students. Once again, this is very important students. This is very important. What is surface integral students? What is surface integral? Integral is f bar dot n bar ds. To evaluate the surface integral students, we are using the formulas. If there is any surface, we are taking projection on xy plane students or yz plane or xz plane students. Okay, if I am taking suppose on xy plane, okay, then double integral s f bar dot n bar ds becomes here double integral r1 f bar dot n bar dx dy by modulus n bar dot k bar students, modulus n bar dot k bar. Now if I am taking the same case to the cube or parallel piped, now this is at any point of z students. So this is region R1. Now what is outward unit normal vector students? K bar. Or students? K bar. So here n bar becomes k students, k bar. So the formula becomes here this one students, this one. Do you understand the difference students? When it is surface, we are taking integral r1 f bar dot n bar dx dy by modulus n bar dot k bar. Okay, if it is cube or parallel piped, okay students, whenever the plane like this, surface like this, okay students, then what is outward unit normal vector students? K bar. So this formula becomes like this students, like this. Okay students, now let us see the concept of physical interpretation of surface integral. Let us continue students. Physical interpretation. What students? Physical interpretation of surface integral. Let us see students. If the vector field f bar represent the flow of the fluid. What students? Suppose there is a fluid like this. What is f bar represent students? F bar represents flow of the fluid students. Flow of the fluid. Then the surface integral represents. Surface integral, dear students, double integral. This double integral represents, that means the value represents the amount. Okay students, the amount of fluid flowing through the surface. Okay students, the amount of the fluid flowing through this surface students per unit time. Students, per unit time. This is physical representation of surface integral. There is another small definition, so same definition. Flux. Oceans, same, both are same students. The amount of fluid, the amount of the fluid flowing through the surface per unit time, it is called flux students. It is called flux of fluid. Flux of fluid. This is about surface integral, some formulae and physical interpretation of surface integral. Surface integral. Hope you understand students. Please subscribe this channel students. Share this video, like this video students. Thank you for watching this video. Jai Hind.